Hello, my name is Albert Wu. I'm a Design Engineering Manager for Power Products at Linear Technology. Today, I'm going to talk about two very exciting new products, the LT3581 and the LT3579 high-powered DC-to-DC converters with fault protection. These products are aimed at high-powered boost, SEPIC, inverting, or flyback switching converters. Example applications include boost converters with output voltages up to 40 volts, inverting converters with negative output voltages, or SEPIC converters where the input voltage can be equal to, higher, or lower than the output. The new fault protection features of these parts allow boost converters to be constructed that can survive output short circuit conditions. This first drawing shows an 8 volt to 16 volt input to 24 volt output boost converter using the LT3579. This circuit is capable of producing up to 1.1 amps of output current. Notice that the power switch is integrated inside of the IC. For the LT3579, a 6 amp 42 volt power switch is included in the IC, while for the LT3581, a 3.3 amp 42 volt switch is included. Because these parts are monolithic ICs, higher switching frequencies are achievable compared to controller parts. The switching frequency can be set to free run between 200 kHz to 2.5 MHz, or an external clock can be used to synchronize the parts. This circuit operates at 1 MHz, allowing the use of a physically small inductor. The inductor used here is only 6.9 by 6.5 by 3 millimeters in size. The peak efficiency of this circuit reaches a very high level of 92%. This second drawing shows an inverting converter using the LT3581. Here the input is 5 volts, while the output is minus 12 volts. This circuit can provide 625 milliamps of output current. This third drawing shows a SEPIC converter using the LT3581. Here the input can span from 3 volts to 16 volts, while the output is a fixed 5 volts. This circuit can provide up to 900 milliamps of output current. These three circuits show just some of the types of applications a user can build using the versatile LT3581 and LT3579. These new parts also feature innovative fault protection features. In a traditional boost converter, a DC path exists between the input and output nodes. When a short circuit occurs on the output, the current in this path can increase uncontrollably and cause one or more components in this path to fail. By adding a few external components, the LT3581 and LT3579 can survive these types of faults. This PMOS resistor and diode are added, as shown, to the converter circuit. When the LT3581 or LT3579 senses that the current in the power path has increased beyond a predetermined level, the part will enter the fault mode. The PMOS device will turn off, breaking the pathway between the input and the output. This protects the components from overheating. The part next enters a timeout period to allow further cooling of the components. When this period of time expires, the part will reinitialize a startup sequence. As these scope shots show, the fault protection in the previous circuit protects against output shorts. In the scope shot on the left, a short is applied at this point. The inductor current builds up as a result and is detected by the chip. The part enters the fault mode and the PMOS is turned off, protecting the circuit. The scope shot on the right shows what happens when the short is continuously present. The part starts up, but each time detects the short and enters the fault mode. After a period of time has expired, the part restarts, but again detects the fault. The same fault protection features can easily be configured to protect against input overvoltage and input reverse voltage conditions. Please consult the product datasheet for more information. In conclusion, the LT3581 and LT3579 are high-powered DC-to-DC converters with integrated power switches and built-in fault protection features. Using these features to construct high-reliability power supplies that can survive multiple types of fault conditions is simple. For additional information, please visit www.linear.com.